Hi everyone, I'm Daniel, and I'll be presenting our CVPR paper, Meta-Personalizing Vision Language Models to Find Name Instances in Video. This is a joint work with Brian Russell, Joseph Civic, Fabian Kaba, and Simon Jenny. Vision language foundation models such as CLIP are excellent in zero-shot classification and retrieval, and can be used to find everyday objects such as dogs. However, when searching our personal photo and video library, we're usually not interested in finding just any dog, but rather a specific instance, like Zach's dog coffee. Also, we want to find the moments where Zach's dog coffee is eating food with the white plates. And the retrieval shows that the CLIP model cannot actually fulfill our needs. So we introduce a personalized vision language model, which allows us to query specific context with our personalized instances and retrieve those personalized moments. Our goal is to tackle two key challenges here. The first one is to adapt vision language models to learn a novel instance from very few examples without overfitting. For this, we introduce meta-personalization, where we learn to personalize a pre-trained vision language model using shared category attributes that represent instance-specific tokens. For example, the illustration on the right, given a large set of videos and the specific instance name, such as "This is my dog Biscuit" from the transcript, and we can learn to meta-personalize vision language model. And during the evaluation, we query a specific context. Our personalized model will give us the personalized moments. Our approach for vision language model personalization has three stages. First, in the meta-personalization stage, we pre-learn a global category features by learning to personalize on a large set of automatically mined personal instances in videos. And this feature will help us better personalize the model later on. And in the second stage, we adapt meta-personalized features and learn from only few examples of user-specific instances at the test time. And during the query time, we take the frozen test time personalized model and use specific context in queries for vision language retrieval. Now let's dive deeper into how our personalized model actually works. First, we use the pre-trained CLIP model as our base. To extend the model's language input vocabulary, we introduce a novel instance-specific tokens W. And these tokens are modeled as the combination of meta-personalized category feature C with an instance-specific weight Z. And the goal of our training is to ensure that only category-specific features are captured, while irrelevant features like background information are discarded. To give you an example, our intuition here is the columns of the global category feature C can correspond to an attribute of that object category, such as color, brand, type, if we are learning car features. Here we also address the challenge of how to get training data for learning our meta-personalization. We propose an automatic mining of name instances in narrative videos. And we are matching a large set of video with their timeline transcript by searching text patterns like "This-Is-My." For example, on the right, we get dog moments when specific instance name "My dog Biscuit" appears. And this could be done automatically. Then we already have the input data for the following meta-personalization training. Along with the data collection, we also present This-Is-My dataset as a challenging benchmark for personal video instance retrieval. Next, let's talk about how we collect data for our meta-personalization approach. We gather personalized instance-specific examples by leveraging videos and their timeline transcript. Our goal in step one is to identify candidate moments where personal instance could be mentioned. We achieve this by searching for possessive text patterns like "This is mine." For example, we find instances aligned with the phrases like "This is our time to talk about" and "This is my friend the guitar" in the transcript. And in the step two, we filter out non-visual instances by comparing the text-to-visual similarity between the instance names and neighboring video shots. and the samples with a low similarity are removed. For example, in the step 2, we can see this is our time to talk about has low similarity to its visual part. So we classify it as non-visual instance. Whereas this is my Fender guitar is visual instance as its high similarity. Finally, in step 3, we recover additional video shots where the instance appears. And we retrieve shots with a high visual similarity to the reference shots. So in this way, we collect personal instances without the needs for human annotations. And let's take a look at some examples from our This-Is-My dataset, which is collected through our automatic mining process. The dataset includes subset for meta-personalization and corrected set for test time personalization and query time retrieval evaluations. And I want to highlight the challenging examples in the query time dataset. So you will notice instances like Alex piano, which is barely visible in the background. Also, the scenes in the query time dataset are very different from the test time personalization video. So this example actually showcased the diversity and complexity of our dataset and task. Next, let's dive into our quantitative results, where we compare our methods with the baselines and other works using This-Is-My video dataset and DeepFashion2 image dataset. We consider 2 settings. The first one is contextualized retrieval, where queries describe a specific context with only a single correct match. And generic retrieval, where queries correspond to a generic prompt with a multiple correct matches. And the results here show that our method outperformed the clip baseline by a large margin. And we also outperformed the state-of-the-art Polara on the DeepFashion2. And let's move on to our qualitative results. We perform queries with specific context, like Zach's dog Coffee is lying down in front of a man and 3 women. Our model successfully retrieved the correct personal instances in the context. Thank you so much for listening, and we hope to see you at the poster section.